Hi, this is Algebra 1's Module 3, Lesson 3, Features of Functions. So here's where we're going to practice doing all those different features we've been talking about. I've already gone ahead and put the different features over here on the side. So for each graph, we're going to determine if the relationship represents a function first, and if so, state the key features of the function. So that's our intercepts, the intervals where they're increasing or decreasing, relative maximums, minimums, symmetries, domain, range, and end behavior. So we are going to put on here, first of all, for number 1, we have to determine if it's a function or not. And basically, if I can do a straight line up and down on here, then and not hit more than 1 point, then it's a function. And so for every x, I only have one y, and that is correct all across here. So we need to find these for all of it. Our domain. So notice how we have closed dots, and domain is our x value, and those closed dots go from -3 to -4. So we're going to go ahead and put on here with the brackets, because that means it's closed. We're including them. -3, comma, -4. Nope, bracket. All right. So for our range, those are our y's. We're going from 0, and the highest point up here is 4. And again, we're including 0 and 4. So 0, 4. Oh, brackets. Not used to doing those on a keyboard. All right, minimum. Let's scoot this over slightly to make sure we can see everything. A minimum. Well, what's the lowest that this one goes? Well, minimum is 0. So my minimum y is 0 when x is 4. So I'm going to put 0 at 4. My maximum is 4, and that's at 1. So I'm going to put 4 at 1. Okay, my y-intercept, it's not really right on the crossroads, but it's less than half. I'm going to say about 3.2. So my coordinate there is 0, comma, 3.2. So when the y is 0, x is when the x is 0, y is 3.2. My x-intercept does cross right over here, right at 4. So then I'm going to put 4, comma, 0. All right, increasing intervals. Well, it is increasing from -3 all the way up to 1. So I'm going to put on here, excuse me, -3, 1. And I am not going to include 1 because it's not continuing to increase. We kind of have a point up there. So it's decreasing basically from 1 all the way down to 4. So 1 is my point that's neither decreasing or increasing. It's kind of my highest point, and the other ones are where they stop. All right. So, and that's pretty much what it is. It begins and ends. We have a solid range of knowing what's going on. All right, so let's look at number 2. Number 2, well, first, is this a function? Do I have only one y value for each x? No. Notice right here, I can draw a straight up and down line, kind of, and right there, those are not, I have 2 points. I have 2 points when I break here. So this is not a function. So I'm done. Let's move on to number 3. All right, so number 3, I can do that up and down and Nope, it's only touching 1 point every time. So let's go ahead and fill in our information. So our domain, we're coming all the way over here. So it's 5, 6, 7, -8, -8 all the way up to, it looks like 10. So I'm going to do my brackets because those are closed dots, -8, comma, 10, close bracket. My range, let's see, looks like it goes to about -3 all the way up to, 10 crosses at 5. So -3 to 5. My minimum point on here, and it looks like it's a -3 at 8. So my maximum would be 5 at 10. Okay, y-intercept. It crosses, again, it's not really an exact point. I'm going to say that 4.2. I kind of like that 0.2 mark. So 0, 4.2. It's less than half, but not too much. And my x, I go over here to see where it crosses. Let's say it's right here, -6. I'm going to say -6.3 this time. -6.3, comma 0. So that's my coordinate of that one. And then it's increasing at 2 points. Actually, it's increasing from that 8, from -8 all the way up. Sorry. Increasing. Yes, it's increasing from -8 all the way up to 0. And then it's increasing again at about 6, 5.5, somewhere in here, probably about 5.5, all the way up to 10. So I have to put 2 of those in here. So -8 all the way up to 0. Again, that one's going to be an opened. And then you do the U symbol because it's and 5.5 all the way up to 10. So this is showing me that I have 2 spots where I'm increasing. The 0 is neither increasing or decreasing, and so is the 5.5. They're kind of the low spots or the high spots, depending on what you're doing. So decreasing would be that space in between. So from 0 to 5.5 is really my only spots that are decreasing. So 0, 5.5. Again, we're going to use parentheses on those because it's not, those are kind of the stopping points. All right, number 4. Moving over here. This one, does each x value have 1 y? Yes, it does. So this is a function, so we can go ahead and fill in our information. So the domain in this case is going from, let's see, that's a 2. So these are going by 0.5s. This is why it's important to label our axes so that we know what we're counting by, especially if it's not by ones. So it looks like it's at 0.5, but it's only dots. It's not really a complete range, is it? It's or a domain. It's not continuous. So we need to list each one of them. So we have 0.5. The next one is at 1. The next one is at 2, 3, and 4. So 2, 3, 4. Okay. Then our range, let me just scoot this over a little bit so I can fit it all on one line. There we go. Okay, so our range, same idea. Because we have dots, we need to list all of the ones we have at specific numbers. So if I'm looking here, my range goes all the way from, looks like halfway on there, so 0.25. And then it goes up to 0.5. And then we get up to 1. And then we get up to 2. And then we're up to 3. Okay, so again, I'm doing lowest to highest, not necessarily left to right on my graph. Minimum. So my lowest point would be that 0.25 at 4. So 0.25 at 4. My maximum would be this guy up here. My 3 at 0.5. Y-intercept, we don't really have one. So we are going to go ahead and put on here none. We don't have where it crosses the x-axis either, so none. Is it increasing anywhere? It is not. That is a none as well. Decreasing. The whole thing is decreasing. So we would say including 0.5 is where it starts all the way to 4. And so that's where our numbers are decreasing, including all those. All right, let's look at number 5. Okay, so for this one, again, let's check and see if we have any points, any x values that have 2. Oh, right here, when x equals -9, we have 2 y values. Going through here, oh, same thing here with 5. When x equals 5, we have 2 y values. So is this a function? No. Not a function. Whoa, that's a crazy n. Not a function. All right, moving on. Let's scroll down, see what our next page brings. All right, number 6. Looking at this one, we've got a graph, our domain. It's kind of hard to see on here. It goes off the screen. It looks like if we're starting at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so we're counting by ones going that way. So it looks like it's -2 is where this goes. And this goes off the screen. So we're actually going to call this infinity. So we're going to do negative brackets, -2, comma. Oh, I don't know if I can do an infinity symbol on here. I might have to draw that one on there. I'm just going to put infinity at this point, INF. Don't know if I have. So an infinity symbol would look like this. So we'd actually put that infinity symbol in there for infinity, but I don't think I can type that on here now that I'm looking at this. So I'm just going to write the words INF, but you would want to put that symbol inside there. Actually, I wonder if I can do that. If I can draw it in here. Kind of. Not a very good one. All right. So, and then that would be a parentheses because infinity goes on forever. Range. Okay, so our range, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so again, it's another 10. So this one is at 9, 8, 7. Maybe 1, 2, 3, 4, 5, 6, 7. Looks like a 7. So I'm going to do range is from -7, comma, and then we're going to do that nice little infinity symbol again. Draw it in there. It's a little bit better one. And parentheses. Okay, minimum. So our lowest point is at -7, -2. So -7, comma, -2. Maximum, we don't really have one on here. So I'm going to put none at the moment. Y-intercept, Well, it crosses, it looks like, at -1. So I'm going to put 0, comma, -1. My x-intercept looks like it's about a half because there's the 1. So we're going to call it 0.5, comma, 0. Increasing. Basically, the whole thing is increasing. So again, we started at -2, and we're going to go on to infinity. -2 to infinity. And we actually don't have a decreasing spot. And I'm going to add an end behavior here because we have one where it's going on forever. So our end behavior is as x goes to going to as I'm going to write it down below so we can see it better. As x goes to infinity, y goes to infinity. All right. So that's how we'd write those on here. 7. Let's take a look at this guy. Do we have only 1 point for every x? Yes. Notice how these two are on the same spot, but this one is open and this one is closed. So that means that there is still only one y for every x. All right. So domain. I'm going from basically 0 all the way to 21. Looks like we're counting by ones on here. So domain is from closed 0 to 21 closed. All right, our range. Here's a -2. So that looks like a negative, not quite to the 3. So we're going to say 2.8. -2.8 all the way up to 10. So range is -2.8 to 10. Minimum would be that -2.8 at, where does we see that at? So there's 19, looks like at 18. Maximum would be 10 at 0. I just realized we wrote that wrong over here, didn't we? It's minimum -7 at -2. All right, to go fix my errors there. So the y-intercept looks like it's at 0, 10. So 0, comma 10. X-intercept, we actually have 2 of them because notice it crosses right here and then it crosses again over here. So let's do the first one first. It looks like it's about maybe, 14.5, somewhere in there. So let's do 14.5, comma 0. And the other one is over here at 21, comma 0. Okay, increasing. We have a couple of increasing spots. So it's increasing from 6 till about 8. So let's put that on here. So it's increasing, and it's an open 6, comma 8. And this one would also be open. Where we need our U, and it increases again. We say our low point was about 18 to 21, right? So 18, 21. All right. So then our decreasing is starting at the 0. So here we're decreasing all the way from 0 to 6. So 0 to 6. And again, from 8, we stopped at 8 up there, 8 all the way down to 18. So notice how we had to put both of those in there, and we have our U in between. And so this one, because it has solid start and a finish, we don't have to worry about that end behavior piece. I'm going to go ahead and scoot this one up so that we have room to see our number 8 down here. Okay, so the table on the right represents a continuous function defined on the interval from 0 to 6. So notice our x's are from 0 to 6. Determine the domain, range, and y-intercepts. And based on the table, identify the minimum value and where it's located. All right, so if we're going through on here, let's just start at the top. Our domain, we already said, was 0 to 6, right? That's the two. We start with the 0 on here, and we go to 6. Okay, and they said it was continuous. We don't need to list them all. Range. Well, our lowest is -3, and the highest is 20 in our ranges. So we're going to go -3 to 20. Y-intercept. Well, y is when the x equals 0. Oh, right there. X equals 0, y equals 2. So 0, 2. X-intercept is when y equals 0. Look at that. 0, 2, 0. Now we need to figure out what our minimum is. So if we are looking to figure out our slope, we know it's a continuous. And we're looking at here, the minimum on here is -3. And so we would have our minimum be -3 at 1. Now, the only thing we have to double check here is that notice how here is a 2, it goes down to a -3, and then here is another 2. So we evidently have it cross the x-axis 2 times, right? So we did all the obvious ones, but now we need to figure out where is our second x-intercept. And so what we can do on that is figure out what the slope of this little bit of the line is, because somewhere between here and here, there's another point. So let's come up with a formula to do this. So to find the slope of this, I'm going to take these 2 points and figure out what the slope is between those 2 points. So -3 minus 2 over 1 minus 0. So that's -5 over 1. So I have a slope of 5, -5. So -5x, and I know I have a y-intercept at 2, so I can do +2. So let's see when x equals 0 for this particular line, and we'll know what our second x-intercept is. When y equals 0 to find our x-intercept. So if y equals 0, I'm going to run out of space. Let me do this one down below. So 0 equals -5x plus 2. Well, to solve for this, I need to take away 2 from both sides. So then I'm left with -2 equals -5x. To get rid of the -5, I'm going to divide. So then two negatives cancel to make it a positive. So 2/5 is the same thing as 0.4. So I must have an x-intercept at 0.4. So I'm going to go up here and go back into my box and put and 0, 0.4, 0. So keep in mind that when you're looking at these graphs, it may not be obvious. I mean, we saw those right there. Like, oh, look, there's a 0 on each side. Perfect. We're good. But notice that since it goes below 0 and then comes back up a couple of times, we have to make sure we get both of those points in there. All right. Let's look at 9. So 9 is the same thing. Table represents a discrete function. Oh, so this is discrete. This is not continuous. From 1 to 5, we need to do domain, range, and x and y intercepts, and again, the minimum on here. So what we've got, domain. Well, we have all these numbers, 1, 2, 3, 4, 5, right? We just list all the numbers because it is discrete. Range, let's go in order. We have a 3, a 4, a 5, an 8, and a 10. So that's the order we want to put them in. Nothing doubled on there, so that's good. Y-intercept. Let's see. Can we figure out our y-intercept on here? If it's discrete, then are we going to have any lines in between? No. So we actually have no y-intercept because none is listed. X-intercept. We don't have any zeros in our y, so there is a none on here too. And a minimum, again, all we have are the points that are given to us. So our smallest number for the y is 3. So 3 at 5 would be our minimum. All right, next. Now we have situations that we need to figure out the key features for, and they're very much in general. So we are going to put these down here below. So I've got a little bit more space to write them. But the amount of daylight in hours dependent on the month of the year. So first of all, is that a function? Yes. Daylight is a different time each day. So each month there's a different amount. So it's not going to have one month's going to have two different ones, amount of daylights. And it's for a specific area. So let's see. What kind of x values dependent on the month? So what kind of x values can we have for the months? We really can have any number on there, right? Because you can have a partial month, you can have partway through January and all that. So, and the time changes even within, is consistently changing. So we can actually put all real numbers on here. The range. Think about kind of what we have for hours. What's the longest daylight hours and what's the least daylight hours we might have. So I'm just going to throw some numbers in here. So I think some of the shorter ones would be 9 hours of daylight would be probably depending on our area. And I suppose we could have as many as 15 maybe in the summer. So we're just going to throw those numbers in there. Minimum would be 9 at, would actually be the shortest day of the year, which is the winter solstice. Maximum would be that 15 that we did for our range. And that would be at the summer solstice, right? The June 21st, 20th, that the longest day of the year. So put that in here, solstice. Y-intercept, not sure it would ever do that. So we're going to put none. There's never really going to be a 0 months. X-intercept, it's not going to be one there either because there's never going to be a zero, 0 hours of daylight. You're always going to have some daylight. It would be increasing. We'd be getting more from winter to summer. And enter there. And then we'd be decreasing from summer to winter. So notice how those are kind of part of how that's working is doing that. So let's go look at 11. 11, the first term in a sequence is 36. Each consecutive term is exactly half of the previous term. Okay, so each term in the sequence, that would be a geometric sequence, right? So we're looking at natural numbers. Range would be, I'm going to put 0 here. It's not actually going to reach 0. That's why it's open. And then it's going to go all the way up to 36, right? Because they're going by half, but they're not actually getting to the bottom. So minimum, can't really say because it's going towards 0, but it's never really getting there. The maximum would be 36 at 1, right? Because that's what we started with. Y-intercept, it says you're starting with 36, and that's at 1, so there is none. X-intercept would still be none because, again, you're never reaching 0 on there. Increasing, it's not. And decreasing, always. So it's just, that's what it's doing all the time. And since it is continuing on and on, it's not continuous, but it is continuing, we're going to add an end behavior because it doesn't give us a stopping point. As x approaches infinity, the function approaches 0. Okay, so again, it's going to get really close to 0, but not quite reach it. Okay, 12. Marcus bought a $500 or $900 couch and a 6 months interest-free payment plan. He makes $50 payments to the loan each week. So the domain in this case, if you're thinking about it, what are the x values in here? Well, if he's doing $50 to pay off $900, that's 18 weeks. So he's going to go from 0 to 18 weeks to pay this off. His range is going to be, we're going to, because we technically have payments in there, we're going to do 900 to 0. We could spread it out over, we could spread it and say 900, 850, 800, and then kind of a ... because it's going to be paying them each time. But we're going to go ahead and we would make a graph out of this. So minimum would be at the end, so 0 at 18. Maximum would be what he started with, right? 900 at 0. Y-intercept would be, we have a 0, so 0, 900. X-intercept, we have a 0 there, 18, 0. Increasing, not really at all, right? So decreasing, always on there. All right. Actually, we should do, we actually have numbers to work with here. So let's work with our numbers. It's decreasing from 9, let's see, we do our x's, from 0 to 18. It's doing it the whole time. All right. So we're on 13. First term in a sequence is 36. Each consecutive term is half less than the previous term. So this one is very similar to 11, but not quite the same. It's half less. And so we are going to go ahead and put a domain. Because you're doing, again, a sequence, we're going to put natural numbers. And let's see. We want to do B1, 2, 3, all the way up. So to get it all the way down to 0 would basically be 73. So we're going to go all the way to 73 on here. Range. So the range, again, would keep going. You're doing your numbers up here, and you're going to have 35, 35.5, and 36. So the range is going to go all the way down and then come up, eventually end up at 36. Okay, minimum. We would have a minimum value of 0 at 73. We'd have a maximum value of 36 at 1. That's what we started with. Y-intercept, we don't have any because notice it started at 1, our first term. But we do have an x-intercept because we're going to basically stop it at 0. There is no increasing, and it's basically decreasing from the whole way, right? So it's decreasing. We're going to put over here on this one always because it could technically go below some of those, but we're not going to mess with that right now. All right, 14. Let's see if we have room for this guy over here. Offset these a little bit. Okay, so 14. Let's go ahead and read it. An empty 15-gallon tank is being filled with gasoline at a rate of 2 gallons per minute. All right, so domain. If we have a 15-gallon tank, 2 gallons per minute, that means it'll get done in 7.5 minutes. So 0, 7.5 would be our domain. The range would be how full the tank is. So that's 0 to 15. Our minimum would be 0 at 0, right? Because we're starting with no water in there. And the maximum would be 15 at 7.5. So in 7.5 minutes, we'd have our full tank. Y-intercept, well, probably 0, 0, wouldn't it? Because we don't have any water at 0 minutes. And our x-intercept would also be 0, 0, because that's our starting point. Increasing the whole way, so 0 to 7.5. And there is no decreasing. All right. Got through those. 2 more. All right, so for each equation, sketch a graph and describe the key features of this graph. So first of all, x has to be greater than or equal to 0. So we only want the ones. Let's draw a graph here. I'm going to do, that is a really bad line. This is going to be hard to do, but I can do a line like this. And let's make it a color so we can see it. again. Getting better at these tools, but I'm still having some troubles. Okay. So right on here is this one. And then let's do another one. X is positive. So let's just go ahead and I'm going to do the line across here. Get that right on it. Okay. So if I know that it's a +4, I'm actually going to zoom in a little on here because this is going to be hard to type right on. So if I know it's a +4, then I know that is my X, my y-intercept. So 1, 2, 3, 1, 2, 3, 4. I need a dot on 4. And then I want to go down. We're going to count by ones on here. Down 2 over 1. Down 2 over 1. I have to use my cursor on these. I can't be very accurate. Okay, so down 2 over 1. Down 2 over 1. Down 2 over 1. So that's my slope, rise over run. Just going to do a few of these on here, and let's do another line so that I can connect these a little better. Here we go, because we only want the X for the positives, right? If I can get this line accurate. All right, so now I can go back and type in my information. Okay, so my domain. Well, I'm going from 0 to infinity, probably, right? Because we're just going on forever. So let's draw let's do my infinity line symbol here. Okay. Range. My range is, well, it starts at 4. So 4, but then it goes on forever again too, right? So I need my infinity symbol in here. Kind of. All right. Next, my minimum. Do I have a minimum? Nope. There is no minimum. It's going on forever. My maximum, though, is 4 at 0. My y-intercept, we said up here, was at 4. So 0, 4. My x-intercept is, where does it cross? 1, 2. So it crosses at 2, 0. And then it's increasing. Nope. No increasing intervals, but it's decreasing the whole time. So 0, 2, and here's our infinity mark again. Draw that infinity symbol. So it's decreasing all the way to infinity. And so then let's add some end behavior here, since we're going on forever. End behavior as x approaches infinity, y approaches, and we're going to put negative, because the y is getting smaller the whole time. So it's going towards the negatives. All right, last one. We want to draw this one. So this graph, we have an exponential function. It doesn't give us any restrictions on our x's this time. So let's just draw our grid here. And I'm just going to put it, I don't know, let's put it down here. since we know it's going to be positive. Range. Okay, and we're going to count by ones again, just because that's going to be easiest as we're doing this. Okay, so in our drawing, we're going to need, let's see, 3 to the 0 power is 1. So I need a dot here. 3 to the first power is 3. 3 to the second power is 4, 5, 6, 7, 8, 9 is 9. Let's see, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 27 would be right here, basically. 3 to the third power. All right. So I'm going to make my line really low down here, connect these guys, and go shoot straight up, right? Okay. So I'm going to zoom out just a tad so I can fit my domain and range on here. Okay, so domain. We can pretty much use any x value, can't we? So how we would write that is actually 2 infinity symbols. So we can go from negative infinity. So negative infinity. That better? So negative infinity to positive infinity. All right. And then our range is also going to be, well, it's not going to be negative infinity, because it's never really going to hit 0, but it's going to get really close. And so then it'll be 0 to infinity. And notice I'm not putting the closed brackets because it doesn't actually reach 0. Okay, minimum. We don't really have a minimum. It won't quite reach 0, but it's not really a minimum. Maximum, we don't have a maximum. It's going to go on forever. Y-intercept, it does cross the y at 0, 1. X-intercept, there is none. Increasing, always, right? It's at no point is it not increasing. There is no decreasing. So now we need to put some end behavior on here. End behavior, as x approaches infinity, the function let's put y approaches infinity. So there's kind of how you can do those different situations with your and key features of the graph. So this is a pretty important one in that this is how you use them on here. So thanks for joining us, and see you later.